Hey, what's up, folks? How's it going? So, today's interview question is: what are the best practices for smaller, faster, and more efficient builds and optimized Docker images? So, we'll look at some of the best practices. There are many. So, if you remember just 4 5, that's fine in the interview. So, first one is use official base image. So, official base image like Alpine and Debian Slim are well maintained and secure and minimal. So, if you choose this base image, it will be secure and well maintained, and which reduces the surface attack and improve the security while keeping the image lightweight. Second one is multi-stage builds. Multi-stage builds we already discussed earlier. Multi-stage build and Docker distroless images, right? So distroless images doesn't have a shell and it's more secure, right? And it is size also is less, so surface attack size will be less. So in the multi-stage builds, we have two stages. Stage one where we build a image where we need to install a lot of tools, package manager, etc. But in the develop, like for example, in the development environment, you install a lot of tools. But when you're going to run it, you don't need all these developer tools. So we in the first stage we build it, and in second stage we just copy that app to the distroless image or very small base image. So there are two stages. So, and if you want to see more details, want to know more about it, then uh, you can look at my earlier playlist about multi-stage builds and distro. Okay. So next one is minimize layers. So when you each instruction when it gets executed, it creates a layer. So run, copy, add, it creates a new layer in the Docker images. So more you have run, copy, add, if you repeat them multiple times, it will create more layers. So instead of running apt-get update and then run apt-get install, run rm minus rf, run something, right? So instead of multiple runs, you can have combine them into one run so that it will create one layer. So that's how you can minimize the layers. So what are the benefits? It reduces the final image size and speeds up the deployment. Next option is use a Docker ignore. So you can ignore unnecessary files. You can in the Docker ignore, you can mention what are the files you want to ignore. It should not be part of the build, so you can ignore that. The benefit is reduce build time and avoids including sensitive or unwanted files in the image. Then we have optimized dependencies. For Python, for example, we use recommends.txt, and what are the Python modules, etc. we need, we mention it here. But sometimes what happens, a developer might be using this module, and after few months, they may decide to use some other module, and they may not use this the current one. But sometimes we forget to update it. So we it's keeps list keeps going. So whatever we are not using, just remove them because otherwise it will be part of that. So better to remove them. Once in a while, check whether we are really using all these dependencies or not. Keep it minimal, whatever is required. So keep this benefit is keep the image clean and secure while improving performance. Then use next one is use copy instead of add. So copy is more predictable, while add can unexpectedly extract archives and download remote files. So try to use copy wherever possible instead of add. Then set a fixed user. Don't use root. Create a root user will cause a security risk. Then we can caching efficiently. So Docker builds cache layers. So pressing frequently change instructions at the bottom speed up the builds. So copy instead of keeping in the copy instruction, instead of keeping it in the middle of the Docker file, you keep it at the end, copy run, etc. So that uh, top layer which are not changing, it will be cached, right? So build will be faster. So avoid unnecessary rebuilds and speed up the incremental builds. So order instruction from least to most frequently change. The instruction which are frequently changing, keep them at the bottom. So that way it will be you will be able to you will be able to do caching efficiently. Then we can use linting and scanning tools. There are different linting and scanning tools which will detect efficiencies, security issues, and best practices. Try to keep the image small, as I said about distroless image. Use distroless image. This year .io distroless based Debian. So it reduce attack surface and improve startup times. Then you should tag the image properly. By default, it will tag latest. But if you give a proper version number 1.0.0 or 1.0.1, so it will be like it's a best practice to follow. It allows better tracking and rollback of versions. Then you can use a Docker build wiki, revise Docker build wiki. This is for parallelize and optimize builds for better performance, faster and more efficient image builds. Optimize logging and debugging. Except logging increases storage and CPU usage. So debugging purpose, maybe you will keep that extra logs. But when you are for production, when you are building image, turn off that debug logs. You can have different options, compile option. There are different options. You can turn it off when you're building it for production. But when you're building it for testing, you may want to have a lot of logs. You want to debug it. So it reduces resource consumption and improve debugging efficiency. And periodically clean up unused images. So this avoid wasted disk space from the old or unused images. You can periodically remove unused images. Docker system tool manager that keeps the environment clean and reduces disk usage. So this is the way you can create smaller, faster, and more efficient Docker images. So we'll come to this question, today's multiple choice question quiz. Just quickly revise what we have discussed. Take base image, official base image. Go for multi-stage builds, distroless build. Minimize the number of layers. Okay, run copy in one line instead of running multiple times. Use docker.ignore. Don't include unnecessary files. Optimize the dependencies. Unnecessary dependencies don't include. Try to use copy instead of add. Don't instead of root user, set a fixed user. Enabling caching efficiency. So frequently used commands should be at the bottom. Use a linting and scanning tool. Keep image size small using distroless image. Tag the image properly. Use Docker build kit for parallelize and optimize builds for better performance. Optimize logging and debugging. Extra logging should be turned off in production. And periodically clean up unused images. Okay, so let's have a look at this question. How can you optimize Docker caching in a Docker file? Place frequently change instructions at the top. Place frequently changing instruction at the bottom. Disable caching to speed up the builds. Use add instead of copy. So we discussed this. So what is the answer? Yes, you are right. Answer is B. Place frequently changing instructions at the bottom. So I organize a contest and I post daily challenges on my LinkedIn page, Devops Challenge Hub. You can follow that page and also subscribe to my WhatsApp channel. And please like and subscribe to my YouTube channel for more such interview questions. Thank you.